Let's dive right into this explainer because we're looking at something totally fascinating today: the hidden, invisible limits of modern language models. We talk a lot about AI, right? About how incredibly human it sounds. You type a prompt and the response you get, well, it feels like it's pulling from this deep, pure well of knowledge. But what if I told you that the absolutely most important thing an AI could learn isn't what we've written down, but what we've completely left out? Now, today's massive language models are incredibly powerful. I mean, they process millions of texts, perfectly learning the flow of sentences and how concepts connect. They are literal masters at predicting the probability of the next word. But here is the critical question we have to ask ourselves right now. Will language models stop at just predicting what has already been said? Because if they do, we're actually missing a massive piece of reality. So, moving into part one, the hidden limits of current AI. To really understand why this is a problem, we need to look at the very nature of the data we're feeding these models. The fundamental flaw, the big trap we're falling into right now, is assuming that language data is this pure, objective mirror of reality. It's not. Not even close. Human beings live inside what philosophers call the symbolic order. Basically, our language is pre-filtered. It's built entirely upon established power dynamics, institutional rules, and historical choices. Language inherently dictates exactly how we see the world. It categorizes things, it makes us speak in certain ways, and crucially, it actively prevents us from saying other things. So when an AI trains on all this data, it's really just statistically reproducing human structural realities, flaws and all. And this brilliantly illustrates the exact problem. You've probably heard of Francis Bacon's idols, right? It's a classic philosophical concept about the deeply ingrained prejudices and illusions our minds just naturally fall into. Because these illusions are baked straight into our language, an AI that only learns word probabilities, it doesn't remove those biases. Actually, it just acts like a giant magnifying glass. It statistically reproduces Bacon's idols, so instead of generating new thoughts, it's just intricately repeating our same old human blind spots. Which brings us to part two, the fatal silences created by compression. This is something that happens every single time we speak or write. We constantly use higher-level concepts to compress complex realities. Think about a word like troublemaker. It's a highly compressed concept. We use it all the time to quickly categorize a specific type of behavior. But pause for a second. Think about the immense, messy reality this single word completely erases. When we label a student a troublemaker, we instantly delete a child's hidden fear. We erase a history of relational trauma. We completely ignore a chaotic home environment, or maybe even the massive systemic failure of the school system itself. The label is efficient, sure, but it creates a fatal silence. Or consider a word like evil. We use this to quickly group together terrible actions. But how swiftly does that label compress and hide the complex root causes? It instantly masks underlying realities like profound immaturity, extreme jealousy, deep-seated defense mechanisms, or even social contagion. Now, higher-level concepts are absolutely essential for human thought. They make the world manageable, but they inherently delete nuance. And right now, AI is only learning those compressed labels, not the erased realities underneath. Okay, section 3, the rise of gap-seeking models. This introduces a radical, brand new paradigm. To fix these flaws, we don't just need a better predictor. We need what's called a gap-seeking language model, a system that actually learns the absence of language, not just its presence. The contrast here between traditional AI and this new approach is huge. A traditional AI looks at data and asks, okay, what higher concept explains this pattern? It wants to compress things further and hand you a neat, tidy label. But the gap question? It operates literally like an X-ray. It asks, what disappeared to make this pattern look so stable? It doesn't want to compress. It wants to investigate what was silenced, what was excluded or made invisible, just so that smooth surface could exist in the first place. This distinction is absolutely critical. So, section 4, the 7 steps of new algorithms. How do we actually pull this off? How do we transition an AI from being a simple magnifying glass into an X-ray that actually sees missing structures and voids? Well, there's a blueprint for this. Here are the 7 architectural steps for gap-seeking AI. Step 1 is surface language. It obviously still needs to understand grammar and context, just like current models do. Step 2 moves deeper into concepts and perspectives, mapping out which words form specific worldviews. Step 3 is visualizing worldviews, where the AI literally has to explicitly state what human assumptions are backing an explanation. Then things get really disruptive. Step 4 is pattern distrust. Step 5, missing cause analysis. Step 6, counterfactual generation. And finally, step 7 is grounding verification. Let's look a bit closer at those last few because they're real game changers. A crucial piece here is pattern distrust. An AI shouldn't just be satisfied because it generated some perfectly smooth explanation. In fact, if the logic is too smooth, the AI needs to be suspicious. Perfect logic usually means all the messy nuances were erased. Then you have missing cause analysis, where the AI investigates why something is unsaid. And here's the key. Things aren't just missing by accident. They are structurally omitted because people literally lacked the power to speak, or history didn't keep records, or society flat out lacks the vocabulary to express their reality. Finally, counterfactual generation asks the AI to simulate those marginalized voices. What if the people who were silenced could actually speak? What would our data look like then?
Which brings us to our final part, Section 5, Towards the Unspoken Things. Let's see how all this builds into a final, visionary resolution. Because if we're designing systems to explore the unspoken, they have to be firmly rooted in reality.
Check this out. This is the formula for the future of artificial intelligence. It's a massive shift. It's not just an LLM anymore. It's a large language model plus a worldview analyzer plus an idle detector, a missing cause analyzer, a counterfactual generator, and, this is the linchpin, a grounding verifier. Because exploring the unspoken, that can easily devolve into an intellectual game of wordplay if we aren't careful. The grounding verifier makes sure these newly discovered gaps are actually connected back to physical reality, human experiences, and actual material conditions. Ungrounded symbols, no matter how clever they sound, just become new idols. We need concrete engineering here, not just philosophy. So when you put the whole shebang together, the learning algorithms completely shift away from mere word probabilities. The new AI's core objectives are entirely investigative. Number 1, what is not being said right now? Number 2, why wasn't it said? And number 3, what new concept is needed to make it visible? We're taking the model away from tracking what's loud and frequent and focusing it entirely on the underlying conditions of language itself. We are literally asking the machine to find the blind spots we can't see ourselves.
And I want to leave you with this final, incredibly powerful thought from our source material. A true language model of the future should not be a model that predicts the probability of what has been said, but one that tracks the conditions of what could not be said. Think about that for a second. If our tech only reflects the words of those who had the power, the vocabulary, and the platform to speak, it is never going to show us the full picture of humanity. The real frontier of learning isn't in the data we've gathered, it's in the silences we've left behind. So next time you interact with an AI and it gives you a perfectly smooth, beautifully logical answer, ask yourself, what did it have to erase to make it sound so perfect? Keep seeking the gaps.